And I'll let Keith, you do the honors.
Okay, thank you. Well, it's a pleasure to introduce Chris Evers. Now, I'm going to set the bar kind of high for him. He's the first speaker I've ever seen that brings his own professional photographer with him. So, he's got his photographer with him. It's not out. We appreciate him being here today. Now, Chris is a great guy. I know he's an expert in this field, so I'm really looking forward to it. When I first heard about this technology, the first thing that came to me was a joint presentation with Sammy, because I see a really good tie-in for the military applications here. So this is a great presentation. Chris is such a good guy that I told him I was going to be wearing my bright orange shirt today, and we're color coordinated. He's wearing his bright orange belt today, so there we go. With that, I'll just turn it over to Chris.
Thanks, Keith.
All right. Thank you. And yes, my son Ashton, he is a brown belt in karate. And when I heard about Keith's orange shirt, I said, well, I'll be an orange belt since I left my brown belt at home, apparently. So all I have is my orange belt. But I really appreciate you guys hopping in and joining me. I'm going to grab the little clicker here. And can we cue up that video first? Does it have audio? I didn't ask. Is it if it? I'll tell you what. Let's skip the video. Let's skip the video. We'll hop right in. I wanted you guys to feel comfortable, so I found some archival footage from 2018 pre-storm from one of your illustrious news anchors talking about pavement preservation, because we were here doing a project, but I forgot about the audio part. It's a little more compelling when you hear her and hear the reporter talk. So I forgot about that. But anyway, yes, we're very excited about some new technology. I'll dive in. Pavement technology has been around a long time as a company for almost 50 years, and we do top of the curve pavement preservation. And I've been around a little bit for a little bit of time as well, almost 20 years now in Florida. I was the APWA Florida chapter president in 2012, 2013, and very fond of this branch. One of the things I'm most proud of is Operation Sister City, which we helped put together, APWA, in addition to Palm Beach Gardens, to help out for Hurricane Michael relief. So love this town, love this place. So I'll dive in and kind of get into it. Now, how many of you guys, if you had to rate problems, how many would put carbon dioxide or CO2 emissions? What do you think? High? You guys worried about it? Okay. Smoking. How about common health problems? Smoking is a big problem, right? Terrorism, big problem. Okay. We're going to talk about something, NOx. Does anybody know? Have you heard of NOx? Okay, it's NOx emissions, bad stuff. Okay, well, the World Health Organization just ranked breathing air in many of the urban areas in the world more dangerous than smoking. It actually kills more people. Outdoor air pollution kills more people every year than smoking. So about 3.5 million people worldwide died prematurely. We like to save lives. So pavement preservation doesn't save a lot of lives. We don't hear about pavement preservation. So we're like, we got to get into a different game. We got to change our game. We got to up it. So we decided, let's go after something like air pollution. So here's you hear a lot about cities, and you even hear about livestock. I think Impossible Meat is also going after our market. They're going to try to go after the emissions from the cows. But mobile emissions are a big problem, and the reason being that big honking SUV that you're driving down the road, it emits these NOx emissions, and when those NOx emissions mix with air and sun, they create secondary pollutants, which are obviously that dreaded ground level ozone. Okay, and before I start losing everybody, it's like, oh my gosh, ground level ozone, it's threatening the world. So here's what it is, but in essence, we're not going to spend a ton of time on it. Just know this is what it looks like. This is a view of ground level ozone in one of our cities, and NOx is a major contributor, is the biggest contributor of smog. CO2 is a contributor to global warming, and NOx is as well. But this is what you see when you see cities. Has anybody been to LA? They've got a NOx problem. They don't like to admit it. They've got a NOx problem. Denver, they've got a NOx problem. Okay, so they're going after it a bunch of different ways: solar, green roofs, but what we're not really spending a lot of time and emphasis on is the mobile source. That's what's causing the problem. Cars idle for 24% of the time. Here's another stat, 56% of the NOx emissions are coming from your cars. Now, for those who think the electric vehicles are going to solve the problem, what powers electric vehicles? Electricity. Where does the rest of it come from? Utilities. Where does that come from? Fossil fuel, blah, blah, blah. So it kind of gets to be a circular issue here. So we got to find different ways. This is what kept us up at night. Actually, we didn't know anything about it. We just kind of stumbled upon it, but it's very toxic to humans. So for those folks who have kids like mine, you'll hear in a second how problematic. Now, if you were in denial, it's not just a river in Egypt, it's actually in Florida. Here we have NOx density in Florida, and we have the sea breeze, so a lot of our NOx comes out over the Gulf of Mexico or the Atlantic Ocean. But anybody know what this little area of no NOx is? Lake Okeechobee. So that's pretty interesting as well. So this is a cartoon representation of Ashton. I didn't tell him he was in the presentation. But 1 in 4 American kids has asthma, and 38% is caused by pollution. Okay, that's something that people don't know. Now, I have trouble keeping my slides up to date. They now say it's 9 million deaths. With the World Health Organization, who knows how they count those? There must have been some major NOx cloud that killed an extra 6 million people that we didn't hear about. But anyway, so as far as, I like to blend in some humor and keep it, because it's after lunch. So lung disease, cancer, stroke, heart disease, blah, 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 they're all have some ties in some percentage of the cases to, air pollution. So, obviously, if you're killing 9 million people, there's probably an associated cost, not only in suffering and funeral costs, but also in lack of production for those folks. So, a major, major hit to global GDP. That is a lot of money. Anytime people say T, something with a T, trillions is a lot of money. So here it all is. You can go through. I'm happy to send you all of these slides and many more. But just know that the costs are high. Okay, another thing, local news, NOx, air pollution advisories. Now, has anybody looked on your Apple iPhone? And it's not causing NOx, I promise, other than the charging it. But if you look at now in the corner of your map, it says AQI. That's air quality index. So everybody's beginning to focus on this and measure this, and it's going to be a big deal over the coming years. So smog alert. Now, I don't think your anchor's going to, throw out a smog alert in Panama City, but air is, an issue, and it's pretty important. We breathe it pretty frequently, or at least I like to. So one of the solutions is what we're calling smog-eating roads. And what is a smog-eating road, for crying out loud? Okay, what it is we incorporate, we're still doing the asphalt rejuvenation, still preserving the pavement without getting into those, but we incorporate a material that is just about as magic as it sounds. It's called titanium dioxide. Anybody heard of it? If you use Crest 3D White, which I did this morning. So if you do, it's got titanium dioxide in it, okay? So it's used a lot in white paints. It's used a lot in other industrial applications. It's very reflective, so it's great for some of those properties. And it's the whitest of the white, very white. So it also has this really interesting property where it's got the ability to have photocatalyst. It's a photocatalyst, so it's photocatalysis. Say that 3 times. And what that does, much like photosynthesis, is it starts a reaction whereby it excites the electrons around the, titanium dioxide, and those electrons begin to react with emissions, and they neutralize emissions permanently. So we'll get into that. This is how it works, though. You have to introduce light, so that's the big ball of fire. Also could be the street lights, now that those are LED. And what that does is when it hits the titanium dioxide impregnated road, it creates this photocatalytic reaction. Much like photosynthesis, it just happens 100% of the time. So as long as some light source is introduced to it, it starts exciting the electrons, which is really cool. So this is what it does. Blah, 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 photo degradation, whatever. We only have 30 minutes. So the TiO2 forms these electron holes, and all of a sudden, this magic voila happens, and it neutralizes the emissions, sometimes upwards of 50, 60%. Now, everybody fan of bike lanes, right? Ride sharing? Everybody ride share to get here? I saw only 2 cars in the parking lot, so I saw a couple bikes. So we can only move the needle like just a fraction. And you know what's been filtering the NOx emissions lately? The human lung. So anybody riding their bike, trying to cut down on the pollution, they're filtering the pollution for us. That's not good. So, okay. What would it do if we didn't have NOx in the air? Well, it would cut that dreaded acid rain. Now, I haven't been hearing about that. I remember reading my weekly reader in the 80s, and acid rain was whatever, it's going to be a big problem. But it's highly toxic. Obviously, nitrites are highly toxic. So this process of producing this reaction is going to cut the NOx in the air and therefore reduce the incidence, which also is going to help us with both airshed and watershed management. So we'll get into that as well. How about the heat island effect? You've heard about all those deaths due to the heat island effect, right? No? Okay, so the heat island effect is really fascinating. What it says is that a rural environment is going to cool off at night much faster than a city environment, because we have these buildings and pavements, and those hold radiant heat. This we did not know about. We didn't know that this was going to have an effect, but I'm going to tell you some of the exciting things about this as well. So lots of issues though, but if we can lower the solar, basically it's the SRI is the number, but it's measures solar reflectivity index, and asphalt has a very low reflectivity index, so about like a 0.05 or 0.08, and we'll see that in a second. But if we can raise that reflectivity of the pavement without causing problems for people riding on the road, we can cool the pavement. And for every tenth that we can reduce or increase the solar reflectivity, that's upwards of 10-degree difference. Now you guys know oftentimes that, and I'm looking at this black pavement out here, which is a major pet peeve. It's a coal tar sealant, and it's a known carcinogen, but I don't want to get off base. Those people are, I don't know, probably like a medical clinic or something. And so people are dying of it. But that solar reflectivity is very, very low, and it's holding a ton of heat. Don't let Fluffy walk on their pavement, because Fluffy's going to have third-degree burns on his pads. And you see pavement temperatures around 160 degrees. So that's bad. What does that do? That means at night, Panama City does not cool because these guys decided to put a black pavement down, and it causes problems. So you're running your air conditioner more at night than you needed to. So I spent a ton of time on that. But anyway, titanium dioxide is being used in a lot of different places. It's exciting. The Pope, the Jubilee Church, is made of titanium dioxide. Breathe easy, Catholics. So you've got a place to go. The Palazzo Italia, there's some roads that have been used in Mexico City, which they've been known to have a little bit of smog. They have a hospital that will eat smog. And coming to a house in Panama City, whoever will shell it out, the new TiO2 toilet. It's only $10,000, and it will neutralize the emissions, I'm told, in this region here where they occur. I guess they call that mobile source as well. So what it does though is it's activated by light that comes on after you use the bathroom. And I'm told, again, I don't know, it neutralizes the organic material, and so you don't have to clean this toilet. So yeah, my wife ordered one up last night on Amazon. So there's a lot of these technologies out there. So we did not invent the technology of titanium dioxide, but we did discover a way to put it in the roadway. So we'll talk about that. Again, very safe. It's non-toxic. You smear it on your skin before you go to the beach, hopefully, and that is obviously going to produce a protective layer on your skin. So, do they work at night? We talked about that. Actually, the newer LED actually activates the titanium dioxide at night, and that's pretty exciting. So, now, there's a lot of literature about this. And up until a couple years ago, no one had figured out a really good way to incorporate it in roadways because, has anybody priced titanium lately? Well, for those of you who haven't, it's $31,000, give or take, a ton. So it's a little expensive. And so what happened was, if you looked at trying to incorporate it in the full depth of roadways, very, very expensive. You just couldn't do it. It was just too much money. So what we decided to do is, we're good at delivering a liquid that penetrates down in the pavement. We're very good at that. We've been doing that for 50 years. Let's incorporate this into the pavement. It'd be much cheaper. We can just use a couple percent, put it down in the pavement, and voila. So the breakthrough was the ability to deliver it, much like some big pharma has discovered new ways to deliver medication. And so now we can deliver these titanium dioxide nanoparticles down into asphalt or concrete pavements, either one. So what does that do for us? Okay, well, so we've got 3 different products that you can use on it. And let's look at what we discovered when we took it out into the field. So what you would want to know is, okay, if you're putting it on a road, are we going to wear it off? Are we going to wear off the titanium dioxide? And so the important part was to be able to get the parts per million concentration down into the pavement. And this is in millimeters for those of you who are big metric fans. So you can see this is 25 millimeters is an inch. So we are able to get it in diminishing amounts down into the pavement. So if we wear off some of the pavement, it's self-sustaining. Now, how about being able to actually remove the NOx emissions? So they have a chamber. This is Texas A&M. They turn the lights on, or the sun, the simulated sun, into the chamber, introduce the gas, and we see this very rapid, once the electrons get excited, then it almost instantly neutralizes the emissions. So this happens very, very quickly once the electrons reach that kind of critical stage and they're sufficiently amped up. And then this is the reduction that we've seen. So anywhere from ARA1 is the asphalt product, CME is all infrastructure, and litho is concrete, just to kind of give you the technical term. But you can see these percentages. So anywhere from the low to high 50s, got some 60s, some high 40s. So these are very substantial numbers. So then we said, okay, well, let's go look at this in some field applications as we started to shake it out. And we said, well, okay, let's put in a lot of titanium, get the numbers. Well, titanium actually works better when you use a little less of it. So these first batches, we were getting into the 30s and 40s. So a little bit of learning. Once we went back, we decided, okay, let's try it. We actually got Orlando International Airport to test it. This is huge. They have 60 million passengers that go into Orlando International every year. So with these numbers, we ran the tests, and excellent, excellent numbers. And we're like, wait a second, we were using the NOx emissions that a car would put out. We need to adjust the NOx to account for the jet engine. Well, how many percentages is that? And it's thousands of percent for these jet engines. So we tell A&M, and they're like, well, if we go any more than 400% of what the car does, we might blow up the chamber. Like, okay, don't hurt yourselves, okay? Don't do that. So they put it up to 400%. We just got those results back, and those were the high 70% reduction. So there's a point where we're going to have to adjust the chamber or the size or something to account for jet engines. And certainly for Air Force, that would certainly be the case, because thankfully your average everyday minivan is quite different than the F-35 as far as emissions. So now this is the other thing that's really exciting about this is we looked at this urban heat island, okay? And again, we knew nothing about this. We're like, well, I wonder, it's reflective, I wonder if we can measure this. So we went back and we ran these numbers. We just got these back like yesterday, and I threw this slide together. And this is from the Orlando International Airport and then a Charlotte County project. And so what the numbers showed is that traditional numbers, and we cleaned it up, took a decimal out and a zero. So 0.9 is basically a 0.09. That's very low. That's asphalt. That's newer asphalt. 0.08, very low. Concrete is in the 0.2 range. To qualify for LEED credits, if you can increase the solar reflectivity above a 0.29, you actually can qualify for LEED credits. So this is really important because we have found now that using this, these products can apply for and get LEED or Envision points. So if you have a parking lot, if you have any other facilities that you want to get those LEED points, it's a very cost-effective way to do it. So we were able to move those numbers up from a 0.09, 0.08 to a 0.39 and 0.4. So remember, every tenth of a point is about 10-degree difference, 7 to 10 degrees. So this means that the pavement temperature will be somewhere in the magnitude of 30 degrees cooler. Now that is tremendous because if we think about urban heat island, if you put that in a big enough area, that means everybody can lower the thermostat, there's less energy use, and also the other thing that's fantastic about this, we haven't studied this yet, is what kind of reduction in aging your asphalt pavements happen if the pavement is 30 degrees cooler, because most of the distress is caused by oxidation and heat, aging, over the 10 to 20 years that your asphalt is down. So I know everybody's super excited about that, I can tell. But it's really a game changer, and it's one that not only is going to help us on the NOx emissions by reducing those, but the other thing is what happens from time to time on pavement? We get rain. And what happens when a rain collects and it's now stormwater? And that stormwater is superheated because the pavement is 140, 150, 160 degrees. Now that stormwater goes somewhere, and that's why we get algae blooms, right? And we get problems. So if we can lower the temperature of the roadway, we can also lower the incidences of some of these stormwater challenges. And again, we weren't thinking about that. So somebody from NASA was in this presentation, and they were like, did you think about the superheated stormwater? And I'm like, I think about that every day. And then I'm like back there like changing my slide real quick. So that's what's exciting. So again, this is really exciting. Hopefully you're kind of getting the feeling from that. But it requires no change in consumer behavior. That's what's awesome about it. Other than the POWorks arena, and as far as consumers being able to put this material out. And so when we looked at this as forests, everybody likes to plant trees. So 1 mile of TiO2 road equates to planting a 20-acre forest. Well, what's cool about that is we can't plant a 20-acre forest in downtown LA. It's just very difficult. Even the environmentalists haven't figured out a way to kind of make that happen. So we can offset, with that mile, we can offset the emissions of up to 4,000 cars a day. So that's really significant. That's like just a bunch of cars disappearing and not happening. So these TiO2 bearing roads, you come through, and I love it when we can throw anthropogenic pollutants. If we can throw that slide in there, that's awesome. So the other thing is, without getting into too many details, is it will change the way water sheets off the road because it's very super hydrophilic and super hydrophobic. Means TiO2 apparently hates water, and it sheets water off about 5 times faster. Again, we're starting to get into this. Somebody much smarter said, "Did you know this?" And we're like, "Well, put it in the PowerPoint. Let's do it." So then, as far as this is kind of interesting. Sometimes it's better to be lucky than good, and sometimes it's good to be both. So. Even breathing is a risk in one of Orlando's poorest neighborhoods. HuffPost runs this article. Orlando's like, oh my gosh, we're getting hammered. Wait a second, didn't we just do that TiO2 test section in Paramore? Yes, we did. So we trot that out. Now all of a sudden the city is applying for a federal grant to treat the entire 3 poor neighborhoods around I-4 in this downtown Orlando. We should know the 90-page submittal just was completed on Monday, so we should know real shortly. But this is what it looked like. So this is the shot. This is the roadway. It's kind of a 3-lane arterial, and then here we put the titanium dioxide bearing material into it. We also did it in Orlando International Airport, this test section. This is what it looked like after. It's fresh, so it's kind of a darker hue, but it dries translucent. It has to be translucent. This is what it looks like going down. It has to be translucent so that the titanium dioxide gets exposed to the sunlight. So that's kind of a shot of it right there. And then over there we are applying it onto the concrete section as well. And then there's what that looks like afterwards, obviously. So when you look at it, it's pretty, I would say, pedestrian looking. You go down there and it doesn't have that feeling of, wow, this is going to save the world. But it's what's in it that really makes a big difference, because as we look at it, transportation is such a massive producer of greenhouse gas inventories, and 1 ton of NOx is equivalent to 298 tons of CO2 as far as what it does for global warming. So anyway, that's what happens. So you see all of these things. Now, anybody want to know how much it costs? Yes?
How much does it cost?
Excellent. Well, I'm glad. Today only. No. What you remember that toilet? That toilet was $10,000. Now, I personally wasn't moved to make that purchase, but we have calculated that a 1 lane mile of roadway treated with TiO2 would actually be around the same amount as 1 toilet. So about $10,000, or it's about $1.40 per square yard. So very, very cost-effective approach. So now, anybody want to know how long it lasts?
Mm-hmm. Yeah.
Okay. So the good news is that once we spray it, it lasts for the entire life of the pavement. It also makes the pavement last longer, so that's the good news. So if your pavement is concrete and you're a concrete industry person, that's 100 years, they'll tell you. So if it's asphalt, could be 20-year design life, could be 40 years on concrete. I kind of jest a little bit when they're not in the room. But it's really long lasting because the reaction does not consume the catalyst or the titanium dioxide. So the more we're looking at this, we're like, okay, that's really cool. We spray it 1 time and it's there for the entire life of that pavement. When they mill it up and remove it, it's completely inert, it's not toxic, so it goes back to the asphalt plant to be recycled and lives to fight another day. So that part is pretty cool. Now, any other questions? Yes?
Well, when you're going to do wrap material back into the pavement, does that help increase the
NOx, the magic. So the only problem with once it goes back into the asphalt plant to be remanufactured as virgin asphalt is that it's coated by the asphalt. So it's the same reason why we can't just put titanium into the asphalt plant, because the asphalt cement, the black material, coats the titanium, and the titanium won't work unless it's exposed to sun.
So you've got 2 separate processes when you're applying something to a road. You've got the rejuvenation and then the
titanium dioxide.
Over.
Those happen at the same time, so we've actually put the titanium dioxide in the rejuvenator, so it's just 1 application. And then if you want to keep rejuvenating the roadway, you don't need to put the titanium in again. You're just putting the standard, reclamite, for instance, into the pavement. Yes, sir.
How many tons of pollution is generated for every ton of titanium?
Oh, for production of titanium. Well, I don't have my spreadsheet with me, but I will email that because I actually have looked at it. So much like cement, see, nobody looks at that data, so that's very crafty. Cement production is a huge polluter. So it's nowhere near what you see with normal industrial production, because it's just a tiny fraction. We're only having to put a few % in. If we put too much in, it actually has reduced efficiency. So titanium dioxide, like my children, my twins, need space. They need space from each other. If they're too close to each other, fights occur. So that's it. But as far as the reduction, if you look at what a mile of road will reduce, depending on the amount of traffic, like when we looked at Orlando International, we could, by treating all of the airfield pavement, we could reduce the effect of air pollution back into the early 1990s as far as their passengers, the number of passengers they were getting. Kevin?
I have a question as far as water quality. So I'm not sure if it's too early or not to tell, but when you've applied it, do you get credit from a water quality standpoint through agencies and permitting?
That's a great question. We're right now working on a pilot project for that, so we don't know that yet. It's one of those things where a lot of the water quality or lead, they want all these submittals first, and then they'll kind of tell you, yes, that'll qualify. So we think that it makes a lot of sense to us that it would, but we're slightly biased, and they want more data than just my wonderful PowerPoint. So we had to submit, like, for the urban heat island for LEED, it was about a 14-page submittal. For that federal grant, there's a federal grant mechanism called the Congestion Mitigation Air Quality, and the feds will pay 80% of a local agency's cost to do something to mitigate air pollution. So what we're trying to do now is unlock that potential. If we could get federal money into local agencies, it's a huge boost, because then at that point, the federal highway folks are paying for you to preserve your pavements, and obviously, deal with the air pollution. But so we're still working on that. In other words.
Yeah, I mean, I think that'd be a great aspect to it.
Yeah, definitely.
Sell
Like the water
itself in
management
that,
districts
yeah.
and those folks have to see a lot of data too first. But that Paramore project is a huge project. They're treating the roadways, even the sidewalks. So it'd be pretty cool. Yes, sir.
So I've been watching this study out in LA where they're literally just painting the roads white.
Yes, I know about that one.
Same concept, they're trying to increase the albedo, and
This.
I'm just wondering how that compares.
Yes. So did anybody see that where the mayor's out there and we're going to lower 5 degrees and paint the roads white? And the problem is that was about $5 a square yard. The other problem is if any of you have ever driven on, which I don't think you have, a white painted road in LA, that would be a problem. This is not working on a visual. It's ultraviolet. It's working on a level that you're not going to see. It's not going to bother you. Albedo is only one of the solar reflectivity. We're working on emissivity. So that's how much heat is actually reflected back. And so albedo, just having it be white, it gets you maybe a 1/10 of a point, and this is going to get you 3/10 of a point. So for LA, and the mayor's going to get a call from me at some point, because he's like, we're going to paint the place white. I'm like, don't do that. But it's not as good a solution, we don't feel like, for urban heat island as this is, especially since this has something else that they desperately need, which is to deal with their NOx problem out there. So the 2-fer and 3-fer is I think really powerful, especially with the cost. Yes, ma'am.
How does the product application affect the stopping ability, the rough surface roughness of the road? Because anytime you add a paint-on application to a roadway, then you increase your risk for skid.
Absolutely. I can't really comment on this without smiling, because we were really worried about that. But we got 2 or 3 points increase in skid resistance with titanium, and the reason is that it's moving the water out of the way really fast. So it's apparently does not like water at all. So what that does is it's changing the shape of the water, and you can't make this stuff up, but I kind of like, you don't have to say that because it sounds ridiculous. So, but it's changing the shape of the water, so instead of beating up and the water causing a problem, it's all kind of linear, and it just moves out of the tire's way, and the tire pushes it out of the way. And so what we're finding is that we can add friction by putting titanium dioxide, because our normal application,
For wet
we
roads.
reduced for obviously we don't apply it on a wet road, but when the water hits it, and even in the interim, because it's wet when we put it down, when we tested it immediately after, so we should have had lower skid. We were like, okay, let's brace for impact, and he's like, these numbers are in the low 40s, and we were expecting them to be in the mid 30s for skid, and we're like, okay, that's crazy. So we start looking at it, and it's because it's this super hydrophilic, material, and that causes the water to get out of the way faster. Yes, sheeting action. So, yes, sir.
Excuse me, are y'all looking to apply it for roofs also?
So there is a material called Noxite, and it's been placed on a roof. It's actually a roof that has titanium dioxide in it. The name of the company is Icopol. They're Scandi, I think. And so they've actually put a roof on the Alachua County 911 Center. The problem with roofs, and the reason we think that it's better on the roads, is it's kind of far from the source of the pollution. So by that time, the NOx is actually mixing with the air and the sun already. And so what this is doing is, if you look at the mobile point that it's emitting, might be a couple feet off the ground, and so we're getting it immediately. But yes, we could apply this on a roof. We can apply it on barrier wall, bridge decks. We've done a bridge deck. So we can apply it on a lot of those different areas, as long as we don't violate someone's patent, obviously. But Alcoa is using it on aluminum. They're using it to coat glass, because then you don't have to clean the windows. It literally, the dirt won't stick to the side of the window. They're using it now they're even using it on the space station, because it destroys bacteria when light hits it, and the bacteria is on the titanium dioxide. So it's a really phenomenal thing. So it's kind of crazy, and I catch myself going, okay, so dial it back. So it sounds good. Yes, sir.
Two for you. What effect does it have on striping, and how quickly can it be placed on new asphalt?
Okay, so I'll go backwards. For new asphalt, so it can be placed immediately within the MOT even. We would call that kind of a construction seal. Because it's translucent, you don't have to restripe at all. That's similar to what we do with Bay County and Panama City for the city, where we didn't have to restripe. We actually are going in and putting it right over the existing thermo or line paint, and it's translucent, so it'll make the line striping look a little dull and greasy until you get a rain, which these days is the afternoon, and you're going to go. So it's
Curious about applications on newer porous asphalt.
yes. So we're testing that for FDOT on one of their friction courses next month. And so it's going to penetrate deeper. So we might have to adjust the shot rate because it's really drinking it because it's so porous. But it still works. And it's going to get the titanium deeper into the pavement. And then there's air around those voids. So it won't affect anything other than construction-wise. We'll have to adjust the application rate. So you guys have awesome questions. Yes?
And I almost hate to ask this next one because everything sounds so good, all the answers have been so positive.
Yeah.
Are there any negative effects?
Yes, okay, thank you, because I feel like I'm kind of, you guys are putting softballs up there. There is a humongous negative. I forgot to tell you this is the humongous negative, is if you only put it on in front of grandma's house, it's not gonna move the needle very much. So you need scale to really do what you want to do with it. So, and I'm kind of laughing, but it's like, okay, Mr. Smith is really upset about his air quality. Okay, let's go treat right in front of his road, and you're like, okay, but the air moves and stuff. And so that's why, like for Paramore, we're treating the entire neighborhood. So it's going to take some commitment from government and finding some creative ways to address this, because you have to find a way to deploy it. And so, that's why, you're not going to see private communities go treat their pavements. Now, we can make the case that it would be fantastic to do because of all these secondary benefits. But what we need to do to really get the most out of it is deploy it in larger, areas. Because just treating, 10th Street or something is it's like, oh man, the people on 10th Street are telling us that their breathing is really improved. So you need to be able to deploy it in larger amounts. Yes, sir.
You had a comment that the NiO2 neutralizes emissions. What are the emissions code?
That's another great question. So
or?
yeah, absolutely. So what happens is it turns from gas state to solid state. So it's sequestered, drops down, and kind of forms like a salt or brine look on the surface of the pavement. Now, what is that? It's actually taking it from N2O, so it's actually turning it to NO3, which is a nitrate. Now, a nitrate is 800 times less toxic than nitrites. So nitrates actually, they're only about 22.5% nitrogen, and they're going to move off into the stormwater collection or into the vegetation, and they don't have a large effect on it. So it also releases some water, a little bit of water, H2O. So there's a reaction, chemical reaction that's occurring there, but that's what it's doing, is it's turning into NO3. Yeah.
I'm just curious, I mean, as great as this one of your products sounds, why hasn't it been more predominant, considering the plant is going to be destroyed in about 10
Yes, I did hear that too. We're watching the same stuff. So, one of the major reasons is that, we just got out there and started doing this. So, I guess they were waiting for us to get started, but but a lot of these projects are literally this year. So that Orlando International Airport, that was like several months ago. Some of this data is less than a week old. So we're super excited about it, and we're start talking about it. But yeah, until you see us on 60 Minutes or some of those, it takes a little bit of time to roll out something new like this. And then also, the biggest reason is, as you guys know, is the bureaucratic red tape that you have to go through to get federal funds and some of these things unlocked. Because if we can do that, there's even some of the federal highway folks that are like, we'll pay 100% of the agency doing this because we think it holds so much promise. So if you can imagine that, I mean, it's a lot easier to get people to do it if it's paid for.
As a city engineer, I do that.
Yes, exactly. Yes, sir.
Is this a function of surface area, or that's a two-part question?
Okay, yeah,
So therefore, if we were to spray this on an open graded asphalt,
right.
which it actually has 3 to 4 times the surface area of a smooth surface,
Yep.
then it would be 3 to 4 times greater effectiveness.
So I wouldn't make that case unless we tried it, which we're doing for FDOT. So we don't know that for sure if there's a linear equation, but it is definitely surface area and airflow. There's a lot of variables, but if you think about it, it makes sense what you're saying, because obviously it's very different than like a dense graded or a concrete pavement, because that NOx emission is going to move around and be exposed to more TiO2. So I think what you're saying makes a lot of sense. I just can't tell you with certainty that we have the data yet to say that there's an amount 3 to 4 times, but it makes sense. And we think for a lot of reasons that, because we're using a lot of porous asphalt to deal with some of the stormwater issues too. So we think there's a lot of reasons beyond just the NOx to use it in instance. So, George.
Somewhere along the line, I got my head that titanium was a strategic metal. And so is it a?
This is strategic.
You start taking
yeah.
Are
we going to build the cells with it?
Is General Dynamics going to go nuts because you're taking away from their jet engine?
Yes, they have not called me yet,
Yeah, okay.
but I'm hoping that they do. No, so there is some of that. So this is there's different types of titanium dioxide, and so this is more of an industrial instead of a DoD like the metal. I mean, it is the metal, but there's a mining, and this is from what they've told us, it's using like a different base stock than what they use for like what the military uses. So we don't think that's going to cause an impact, but we're willing to try to impact it. This has been great. I mean, there's a lot of questions. I really enjoyed fielding these, and so you guys have been a great audience. I hope I didn't take up too much of you guys' time.
That was an excellent presentation.
Thanks, I appreciate it.
Oh, yeah. I've never laughed so hard in a technical presentation. I don't know what that means. But it's very good.
Yeah, let's do it.
I think everybody liked it except for Ken Knox. He's offended that you're talking about him in that way. It's a small token of our appreciation. Going from our post, thank you for coming out.
Awesome. Thanks, I appreciate it.
It's
It's titanium. Well, that's awesome. I promise we won't
Chris will be up here for orders after the meeting if anybody would like to. So thank you for coming
Thanks.
out.